Hello, class. Welcome to today's lesson. For today's lesson, you will want a filled out unit circle. And just to let you know where we have been and where we're headed, we've completed the first half of chapter 4, and we are now going to get into section 4.5, then 4.6, then 4.7. So to begin today's lesson, I don't think you have to take any notes yet. So for now, just pay attention, and when the time comes, I will let you know that you should be taking notes. So what we're going to be doing today is we're going to start section 4.5, and we're going to graph our basic sine graph. So we're going to find out what y equals sine of x looks like if you graph it. So first thing to notice is that this graph paper is very different than the graph paper you're used to. The x are going to be angles. So my x-axis, that's why you can see we have pi's, multiples of pi here. And my y-axis will be the ratios, because those are the output when you find the sine of an angle. And as you can see, my y-axis is very small here, smaller than usual, because the highest sign can go as 1 and the lowest sign can go as -1. So I certainly don't need to go all the way up to 10. 2 is even higher than I'm going to need. So since this is our very first time making this graph, what I'm going to do is I'm going to plot a lot of points. And I don't think you need to write this part down because it's going to be just a lot of copying down a table. So to begin, before we can start plotting points, I would just like you to look and think about what the scale on the x-axis is. Because if you look, this is marked as pi over 2 and this is marked as pi and so on. But what is one tick mark? What does one tick mark represent? One tick mark represents pi over 6. So this is pi over 6. And the next one's 2 pi over 6. But if we reduce 2 pi over 6, we get pi over 3. This is 3 pi over 6. This next one's 4 pi over 6. What do we get when we reduce 4 pi over 6? 2 pi over 3, 5 pi over 6, and 6 pi over 6 is pi. So each tick mark is pi over 6. So to begin creating a table, we are going to plug in angles because x is our angle, and we're going to get out a ratio for y, and we're going to plot those points. So to start, if I plug in 0, take a look at your unit circle, find the angle of 0, look at the ordered pair. The ordered pair is 1, 0. Sine is the y-coordinate. That makes the ratio 0. So 0, 0 is the first point that I have on my graph, and it is an x-intercept and a y-intercept. Next, we're going to plug in pi over 6. So we're going to find the sine of pi over 6. So take a look at your unit circle, find the angle pi over 6. Find the ordered pair. The ordered pair is radical 3 over 2, comma 1/2. The y-coordinate is sine. So the point that I want to plot is pi over 6, 1/2. Pi over 4 is the next angle on your unit circle. And the sine of pi over 4 is radical 2 over 2. And I don't have pi over 4 listed here, but since we know that this is 30 and this is 60 degrees, then 45 must be halfway between. So that's where pi over 4 is going to go. And radical 2 over 2, I don't know exactly where to put that on my y-axis. So I put that into my calculator before and got a decimal approximation of 0.71. So I can plot pi over 4, 0.71. Maybe right around there. The next tick mark on my x-axis is pi over 3. So take a look at your unit circle, look at pi over 3. The y-coordinate there is radical 3 over 2. And again, I'm going to need a decimal approximation for that if I'm going to plot that point. So I put it into my calculator earlier and got 0.87. So maybe right about there. Pi over 2 is next. The sine of pi over 2, look at your unit circle. Find the angle pi over 2 up there. The y-coordinate is 1. So I'm plotting the point, pi over 2, 1. Okay, next angle. The next angle is 2 pi over 3. So look at your unit circle for 2 pi over 3. You get radical 3 over 2, which is still about 0.87. And I'm going to go ahead and skip over. I know the next one on your unit circle is 3 pi over 4, but we don't have the pi over 4s listed here as tick marks on the x-axis. So let's jump to 5 pi over 6. So for 5 pi over 6, the sine of 5 pi over 6 is 1/2. And then for pi, the sine of pi, take a look over there out there to the left, the sine of pi is 0. So here's the beginning of my basic sine graph. The beginning of my basic sine graph looks like that. Now, that's not the entire graph, so we need to keep plotting points. So for my next set of points here, let's continue on our way. This is 7 pi over 6. This will be 4 pi over 3, then 3 pi over 2, and so on. So look at your unit circle, please. Find 7 pi over 6. Look at the ordered pair. What is the y-coordinate? It's -1/2. So that means I'm going to plot the point 7 pi over 6, -1/2. For 4 pi over 3, the y-coordinate on your unit circle is negative radical 3 over 2. So that's going to be about -0.86. Look at 3 pi over 2 on your unit circle. Down there, the y-coordinate is -1. So on my graph, I'm going to plot 3 pi over 2, -1. And I think we start to see what's happening here. So what I'm going to suggest is that we don't continue with every single tick mark here. So let's skip over 5 pi over 3 and 11 pi over 6. Let's see what happens at 2 pi. At 2 pi, look on your unit circle at 2 pi. The ordered pair is 1, 0. So sine is 0. And I think you might be comfortable enough if I go ahead and fill this in down here. And if you're not comfortable, you can take a moment and find out what the sine of 5 pi over 3 and the sine of 11 pi over 6 are. And what you'll see is that your graph begins as a hill followed by a valley. Now, that's not the entire sine graph because we can plug in angles that are bigger than 2 pi. So for example, if we plug in 5 pi over 2, take a look at your unit circle. 5 pi over 2 is all the way around and then back up another pi over 2. That's coterminal with 90 degrees. So up there, the y-coordinate is 1. And then let's jump over to 3 pi. 3 pi, if you sketch 3 pi or look at your unit circle for 3 pi, it's all the way around and another pi. So you're coterminal with pi. The ordered pair there is -1, 0. So the sine of 3 pi is 0. And I think what you'll see here is that you have another hill. So I'm going to go ahead and fill that in. I'm not going to connect these with straight segments because this is going to end up being a repeating graph. So you're going to have these nice smooth hills followed by a smooth valley, another hill. Another way to discuss this is with concavity. This part is concave down, like a frown, and then this part is concave up like a smile. So we're not going to connect these with straight segments. They're going to be nice curves. And then what's going to happen after this is the graph is going to repeat. So if we were to continue this table of values out to the right, what you would find is that by the time you get out to 7 pi over 2, you're going to be down at -1 again. And by the time you get out to 4 pi, you're going to be back up at 0 again. And the graph does not end here. The graph continues on, and it actually continues on forever. Now, that's what happens to the right of the y-axis. We have to now consider negative angles. Can we plug in negative angles? Absolutely. So what we want to do now is we want to look at the unit circle, think about negative pi over 2, and the y-coordinate there would be -1. We want to think of the unit circle, look at your unit circle, think of negative pi. The y-coordinate at that point is 0. For -3 pi over 2, we're going to be up coterminal with 90 degrees or pi over 2. So my y-coordinate is 1. And then if we go to -2 pi, I'm back to 0 for that y-coordinate. And once again, I'm not going to connect these with straight segments. I'm going to make nice hills and valleys. And that's what our basic sine graph looks like. Now, the sine graph does not end at -2 pi, and it does not end at 4 pi. This graph goes forever to the left and the right. So that means that the domain is all real numbers. And guys, still no need to take notes. We'll get to all the notes in just a minute or so. While we're talking domain, let's think about the range. The range is not all real numbers. The range is -1 to 1 with brackets because we do go all the way down to -1 and we do go all the way up to 1 for our range. Another important thing to note here is the y-intercept. The y-intercept is 0, 0. It is also an x-intercept. I put a little star next to it. You'll see why tomorrow. Another thing to think about when you look at this graph, even, odd, or neither. For the graph to be even, you'd be symmetric with respect to the y-axis. For the graph to be odd, you would have symmetry with respect to the origin. The way we like to think of that is 180-degree rotational symmetry. Sine is an odd function. The basic sine graph is odd because if we were to spin this paper 180, the graph would look the same as before. So if you look from that y-intercept, that would still be 0, 0. It goes up to the right to a hill and down to the left to a valley. Let me put it back. So I said from the y-intercept at 0, 0, it goes up to the right with a hill and down to the left with a valley. So if you spin this graph 180, it does map onto itself. This is an odd function. Another thing I mentioned is that this graph repeats. Can you take a look at that graph and determine how far you have to go before the graph repeats? You need to go 2 pi. So for example, if I look at this, taking one hill is not enough because if the graph were to repeat after that, it would just be hill, then hill, then hill, and that's not what the graph looks like. So if we take a hill and a valley, and that distance is 2 pi, the graph maps onto itself because if we continue the graph after that point, we have all the same things happening. So if I could pick this up and move it 2 pi to the left or 2 pi to the right, it would map onto itself. And you don't have to take that interval of 2 pi. You can take any interval of 2 pi, and you should see that the graph does repeat after that. So for example, if I were to start here, let's see if I can show this with a different color. This is a length of 2 pi. So that's a length of 2 pi. And if I were to start up here, and I'm 2 pi apart, you can see that I'm tracing the exact same thing at the same time. So every 2 pi, this graph repeats. Another thing to note is our maxes and our mins and our x-intercepts. Our maxes and mins and x-intercepts are going to be very important points on this graph, and they occur at certain types of angles. They occur at quadrant angles. So if you look at this intercept here, it's at 0, that's a quadrant angle. This maximum occurs when the angle is pi over 2, that's a quadrant angle. The intercept occurs when the angle is pi, that's a quadrant angle. This minimum occurs at 3 pi over 2, and that's another quadrant angle. So quadrant angles are going to be very important to us as we talk about our sine, and tomorrow we start talking about our cosine graphs.